So as we go through all of these unit circle projects, I just want you to know a couple of things about the unit circle project, and then I'll take out some more. Okay? First off, the unit circle project is extra credit, and it is summative extra credit. That's the good one. Okay? This is grade changing stuff. Okay? It is worth up to 10 summative points. However, just by doing one does not give you 10 extra credit points. Maybe we give 110 a year. The key word in that is maybe. Okay? We will, when it comes to Unit Circle Project Turn-In Day, which is going to be the 28th of October, which is the Tuesday after your long weekend. One night after school, Mr. Schmeling and I will lay out all of the Unit Circle projects around the room. And we will walk around the room and we will pick out our favorite, the one that we deem to be the best. And then if that one is worthy of a 10, then it gets the 10. Sorry, I'm stepping on the back of my key. Okay? Then it gets the 10. And then everything else is based off, or is judged off of that project. Okay? 3 classifications, or 3, I sent her a picture. She just texted me back. 3 classifications on the judgment call. Originality. You'll see, we've seen it all, but we still see new things every year. This was the first time somebody did a cape. Okay? We've gotten jumpsuits before, we've gotten t-shirts before, but we never had a cape before. Okay? So originality is one. Creativity is one. Okay? Accuracy is one. Just hodgepodging a unit circle will not get you very much. We need you to be accurate. We need you to have the 30-degree gap, the 15-degree gap, the 15-degree gap, the 30-degree gap on all of them. Okay? So that's definitely. And frankly, difficulty also comes into play. And I'll show you what I mean by difficulty as I dig out some of the old projects too. Okay? So if you're following along on the video, sorry you don't get to see them, but you'll see them in class at some point in time soon. So while I put these away, in the back of your note packet, there should be like a page and a half of blank space. And the reason that there is blank space there is for these warm-up problems. Okay? So the last couple of pages in your note packet will leave you always at least a page of a blank page, just so that you can do all of the warm-up problems that aren't in the notes. So while I'm putting some of these unit circle projects away, if you wouldn't mind answering these 6 questions based off of the fact that the sine of t is negative 12 over 13, and we're going to assume that we are on the unit circle. Okay? We're going to assume that we're on the unit circle. Based on your obviosities, okay? You should know sine is negative in which 2 quadrants? 3 and 4, right? Okay? So we are in quadrant 3, or we are in quadrant 4. Without a secondary piece of information, we don't know, so we have to assume that we're in either one of those 2 quadrants. Okay? Sine of negative t, according to your obviosities, so that was obviosity number 2, or excuse me, number 3 answered number 1, and according to obviosity number 6, the sine of negative t is equal to the negative sine of t, so that would be 12/13. Sine of t plus pi, was obviosity number plus pi was 5. That tells me that I'm on the opposite side of the unit circle, so therefore this would be 12/13 also. Sine of t minus 2 pi was obviosity number 4. That puts me at the exact same spot, so that would be negative 12/13. Cosine of t, if sine of t is negative 12/13 and I am on the unit circle, then cosine of t would be equal to 5/13 if I'm in quadrant number 4, but it would be negative 5/13 if I'm in quadrant number 3. So that plus or minus is important because we don't know which quadrant we are truly in. Cotangent of t then would be cosine over sine. So since cosine is plus or minus, cotangent is going to be plus or minus 5/13 divided by 12/13 is 5/12. Yes?
You showed me, figured out the cosine one.
The cosine one? So the unit circle equation was x squared plus y squared, or sine squared plus cosine, or cosine squared plus sine squared is equal to 1. Right? So negative 12/13 squared is 144 over 169. 1 is 169 over 169. Subtract to get x squared, so then that gives me 25 over 169. Square root of 25 169 is 5/13. Other questions? Because sine is negative in quadrants 3 and 4. That's the only thing we have to base it off of. Because we were only given the fact that sine was negative. So sine is positive on the top half of the unit circle. Sine is negative on the bottom half of the unit circle. So I know that I'm on the bottom half of the unit circle, which is quadrants 3 and 4. Okay? All right. So today, we're going to work backwards. Okay? So far what I've said is, I've said the cosine at pi over 6 is question mark, and you've said the square root 3 over 2. Okay? Or we've said that the tangent at 3 pi over 4 is question mark, and you figured out that that's negative 1. Okay? Today what we're going to do is I'm going to say the cosine of theta is 3 pi over 2. Okay? If I say that the cosine of theta is 3 pi over 2, then I go look at my unit circle here, and I would say, oh, well, cosine is x values, so there is 3 pi over 2, so therefore cosine of 3 pi over 2 could be pi over 6. But down here is another cosine, an x value, that's 3 pi over 2. So cosine could also, or so theta I should say, could also be 11 pi over 6. So we've got two options for all of our unit circle values. Okay? In order to find the accurate one, we need a secondary condition. And that secondary condition for us right now is that theta is an acute angle. Okay? So which quadrant are we in if theta is an acute angle? We're in quadrant number 1, because acute angles are less than 90 degrees, and quadrant number 1 is from 0 degrees to 90 degrees. So therefore, now I go back to my unit circle and I say to myself, which angle has a cosine value of 3 pi, or excuse me, of the square root of 3 over 2. And in this particular case, theta here would be pi over 6. Because it's in quadrant number 1. It's an acute angle. It's in quadrant number 1. And it has a cosine value of 3 pi over 2. Not 3 pi over 2, excuse me. Square root of 3 over 2. Okay. Again, sticking in quadrant number 1 because that's where all my acute angles live. Tangent of theta is equal to 1. Tangent of theta is equal to y over x. So if I want my y over x to be equal to 1, what do I need to know about y and x? They have to be the same if it's going to be equal to 1. So where in quadrant number 1 is x equal to y? Pi over 4. So theta here would be pi over 4. Sine of theta is 1/2. So now I'm looking for the y value to be 1/2 in quadrant number 1. That puts me at pi over 6. Agree? Questions, comments, concerns, clarifications? Sticking in quadrant number 1 because theta is an acute angle. Find me where the tangent, or find me the theta that would make my tangent be the square root of 3. Find me the theta that would make my cosecant be the square root of 2. Go. Tangent again was y over x. And since I want the square root of 3 to be not in a fraction, therefore I want the square root of 3 on the top. So I would want this to be the square root of 3 over 2 divided by 1/2. So that puts me at pi over 3. If you didn't see that, you just got to find the tangent at all of your unit or all of your quadrant 1 angles. Okay? Okay? Cosecant of theta is pi over 2. Well, cosecant is 1 over the sine of theta. So that would equal that. Now, because of math, and math being math, I can reciprocal both sides, and it still stays the same. Okay? So therefore, if I reciprocal the left side, that would give me sine of theta. If I reciprocal the right side, that would give me 1 over the square root of 2. Don't like that, because it's not rationalized. So if I multiply by the square root of 2 over the square root of 2, that would give me then square root of 2 over 2, which is in quadrant number 1, which is pi over 4. Now, truly, you shouldn't have had to do all of that work, because the only angle in quadrant 1 that has a square root of 2 in it is pi over 4. So that was your only choice there, because it was in quadrant number 1. Okay? Any questions on those? Let's change it up a little bit. Now let's get out of quadrant number 1. Find me the cosine of theta equaling negative square root 3 over 2 under this condition, and find me the tangent of theta equaling the square root of 3 over 3 under that condition. Go for it. Which quadrant are we in? based off of this, we're in quadrant number 2. So where in quadrant 2 does cosine have a negative square root 3 over 2 value? 5 pi over 6. So theta here is 5 pi over 6. Okay. In this one, which quadrant am I in? Quadrant 3. So where in quadrant 3 is my tangent value square root 3 over 2? 7 pi over 6. So my choices are not 5 pi over 4, right? Because that doesn't have a square root of 3 in it. Okay? Square root 3 over 3 means that I want to have my square root 3 on the bottom, which means that I want to be in the tangent of theta equals negative 1/2 over negative square root 3 over 2 ball game, which then makes this be 1 over the square root of 3, which you should be able to rationalize unit circle denominators in about 4.2 milliseconds by now. Square root of 3 over 3. Okay? So this would be 7 pi over 6. Questions, comments, concerns, clarifications? Let's jump into our old friend SOHCAHTOA. Okay? Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Okay? This only works on right triangles. If you have a non-right triangle, you've got to wait a couple of weeks for us to get to the law of sines and the law of cosines. We will get there, but we won't get there right now. We're just going to stick with right triangle trig here for now. Okay? So, we locked in our angle here at 39 degrees. That's going to be my theta. Because that is where the angle is, this vertical side is my opposite side. The 23 is my adjacent side, and x is the hypotenuse because it is across from or opposite the right angle. Okay? So we're locked in with those. Which one deals with SOHCAH or TOA deals with adjacent and hypotenuse? Cosine is the one that deals with both of those. So now I am going to show you, and I say this not to be mean, but Schmeling was in the last class that I had when I said this, and he 100% wholeheartedly agrees. The work that I show here is the minimal amount of work that you get to show. If you show more than this, great. But if you show less than this, you'll get no credit. We'll give you a 0 on any problem that we do. Meaning if we just see answers on all of these, we're not going to give you any formative credit. We're not going to give you any summative credit. We're not going to give you any homework credit. Okay? You have to show your work. Okay? All right? So the first thing that you're going to do is you're going to set up the fact that this is the cosine of 39 degrees equaling the adjacent 23 over the hypotenuse x. Okay? Now, knowing the fact that this is over 1, and knowing the math trick that you can switch values along the diagonal, so I could switch those two out with each other and not change the value of the problem. Likewise, I could switch these two if I wanted to, and it wouldn't change the value of the problem. If I switch horizontally, that totally changes the problem. So that's not mathematically legal. This is a math trick. So knowing that math trick, you can say that x here is equal to 23 divided by the cosine of 39 degrees. Okay? Now, when you go to calculators, you can use whatever calculator you want to use. We will not answer questions on your calculator in class, like when we're doing it. We will answer questions on the Inspire ones. I want to show you on the Inspire how you can override whatever setting that you're in terms of degrees or radians. So if you go to a calculator page on your Inspire, if you'll notice, I am currently in radians. I know that I'm in radians because it says RAD up here. Okay? No matter what mode I'm in, if I want to go 23 divided by the cosine is under my trig here. If I just type this in under this condition, it's going to assume that my angle is 39 radians, okay? Which is approximately 12 laps around the unit circle, is where 39 radians lives. Okay? So to make this be a degree, I can override the radians by going down here to the pi key, and then right here underneath my pointer, get my pointer out of the way, right there underneath the pi is the degree symbol. And when I type that in, or when I hit enter on that one, it now puts the degree symbol in my problem for me. No matter what mode I'm in, it's going to calculate it at 39 degrees. So then I can figure that out, that my answer is 29.5955, but truthfully, I should look at it as a whole, and I get that. Because we round to 3 decimal places. Okay? So this would be here, x is equal to 29.5954702. If I'm rounding to 3 decimal places, x here is going to be equal to 29.595. No label in the problem, so then that is my answer. With me? Very quickly, we can do this next one. We have my angle here. We have the opposite side here. We have the hypotenuse here. So that is going to be the sine of 66 degrees is equal to x over 50. If I multiply both sides by 50, I get 50 sines of 66 degrees equals x. When you type that in on your calculator, you get 45.67727,288 is x. Rounded to 3 decimal places, 45.677. No labels in the problem. That is equal to x. Okay? With me? Good times. Great spot to end up.